Hello everyone, my name is Akhilesh Tele with student ID 2024190223, integrated master PhD student of SLR. Today I am going to present MMIC design and the technology used for designing MMIC. In this presentation we will talk about Foundry service process, comparison between in-gap and ALGAS HBF 6-inch HBT process flowchart, modeling procedure, transmission line, passive device, layout design rule, and at last we will talk about design rule check. Now, to go into the Foundry service process, we know that the modern Foundry service is Company Limited, and below are the some technical specialist process for the manufacturing MMIC. First, we have to prepare MPW application, then NDS submission, then after we go through be informed of due date of a design kit, then we make the mask, after that we submit, then design rule check, mask making, fabrication, and the last process control monitoring, and at last packaging and delivery. Now GFP HBT process. In this process, it is actually heterojunction bipolar transistor, and it's a semiconductor fabrication technique used to manufacture high performance transistor for various applications, particularly in the wireless communication system. HBT technology is an essential part to provide high performance integrated circuit power amplifier, extremely high linearity, low voltage operation, high efficiency, along with low cost, small size. This is the physical structure of heterojunction bipolar transistor. Now we compare with the gap ammonium gallium arsenide with in-bit gallium phosphate HBT. Now we talk about the lifetime. It is 1 to 2 years, but we can see there is more than the 20 year for indium gallium phosphate, and the main difference by material oxidation problem in aluminum cause short life, less oxidation and defect in indium gallium phosphate. Also, you can see the etching difference, complicated dry etching for aluminum gallium arsenide, while as indium gallium phosphate simple selective wet etching. And while considering the differences, higher L from indium gallium phosphate, heterobipolar junction etching, band alignment. Also, you can see there is the difference in band alignment, but we can see the band alignment of aluminum gallium arsenide is quite high. It's 0.25 eV. The 6-inch HBT front side process flowchart. In this figure, we can see the 6-inch HBT process for front side. First, we have to connect with the emitter, connect emitter isolation, first base pedestal, then base connect. Second, we have to do nitride, the first base pedestal, second base, then we connect, then mesh isolation, third nitride. This is the 6-inch HBT front side flowchart. And for the back side flowchart. This is for backside. We have to do wafer thinning, then backside by photos, backside etching. The characteristic of HBT foundry is its low thermal resistance and reliability, high reliability, less noise. For modeling, actually modeling is mathematical description of the stimulus response electrical behavior of circuit or device. Model used for characterize device circuit. Description, it contains the parameter and of variable parameter for the modeling, and also this should be extracted. Basic model types. This is the physical based on physics and process. Empirical, it is also empirical and semi-empirical too. And this is the modeling procedure for making MMIC or device. First step, we have to select the model, and then we have to go for the measure the device or the circuit, obtain data, extract the parameter, return to the parameter value to the model, simulate the response using model, compare the simulated and measured data, and then finally we have to optimize the parameter value for the matching between the measured and the simulated data. Transmission line. Here we can see there is the difference. This is IMS and IM. There should be difference of 0.3 micrometer in IMS and IM lines configuration, and we can also see the difference between 0.5 micrometer in ABP and ABM. This is the layout for MIM capacitor. Transmission line. The microstrip is a flat strip of conducting material separated from single ground plane by dielectric material substrate such as gallium arsenide. The physical parameter of line metal as we can see from the figure. We have the H for 95 micron and thickness of 1.5 micron, and roughness supposed to be 0 mm. Now while talking about the passive device, we have different passive device: capacitor, resistor, and modeling of MIM capacitor. We have different parameter for modeling. We parallel plate capacitance. We have to also consider the permeability, the area of the plate, and the distance between the electrode. To calculate the capacitance, we have to consider the permeability times area, and it is inversely proportional to the distance between the electrodes. Another passive device is inductor, and we have different types of inductors. Some are spiral and some are square. Spiral inductor component commonly used in radio frequency to store the energy in form of magnetic field, whereas the square inductor passive device component, typically the planar square shaped, provide higher inductance. There are the two types, PA and P are the two types of square inductor. Another passive device is the resistor. Resistor is the passive electronic component. Earlier we told about the IMS, interconnected metal seed, and interconnect metals, and the NCR, nickel chromium resistor. While talking about the interconnected metal seed, IMS layers as bottom layer and provide the structure foundation for the resistor, and it is usually made of conductive materials such as aluminum and copper. Whereas interconnect metal, this is a sandwich between the IMS and NCR layer, and act as intermediary between this. It acts as a bridge. It may consist of various material including dielectric or the insulator layer, to provide electrical isolation and prevent short circuit between IMS and NCR layer. IM layer also help us to define the geometry and the dimension of the resistor. While talking about the NCR nickel chromium resistor, it forms topmost layer of, and consists of the actual resistive element made of nickel chromium aluminum alloy, and this nickel chromium is commonly used resistor material due to its high resistivity and compatibility with the semiconductor fabrication process. The NCR layer is patterned and used to create desired resistor with dimension. Well, now we will talk about the layout design rule. It's involved the adding to solve layout design rules to ensure optimal performance and the manufacturing. For that, we have to select the substrate, proper substrate having the dielectric constant, higher dielectric constant, and the thermal conductivity, and also transmission line designed to control the impedance to minimize the signal loss and the impedance mismatch. Grounding, implement a solid and low impedance ground plane to minimize the ground loop and provide good signal integrity. Isolation, ensure the sufficient isolation between the functional block to prevent unwanted coupling and interference. Layout symmetry, maintain layout symmetry to minimize parasite effect and ensure the balance performance across different frequency and the condition. And also you have to consider the heat dissipation, incorporate the heat sinking structure and the thermal dissipate generated by the active device and the prevent thermal. Now, concrete layout design rule. This layout design rule ensuring the minimum feature size and spacing between the feature that meets the chosen semiconductor fabrication process. Now we will talk some of the example of the concrete layout design rule. Nickel chromium resistor, interconnected metal sheet IMS, interconnect metal IM, second nitride by SNV, APB air bridge post, ABM air bridge metal, and also and the FPL final passivation layer. These are some concrete design layout rules. Now we will talk about the design rule check. Design rule check is a critical step in semiconductor design process, ensuring that the layout adheres to the fabrication requirements and constraints specified by the Foundry process technology. It involves the actual verifying the layout against a set of design rules to detect the violation that could potentially lead to the manufacturing defect or the performance issues. There are the two kinds of design rule checks, quick check and the custom check. In quick check, minimum width and spacing are checked, whereas the custom check, we have design rule, we have to go through the pre-written design rule. Custom check, we define first, we have to define and select the design rule, then we have to run the design rule using different selective rule, load the result, then view any errors that were made, and last we have to do packaging. Now we have gone through the slide. In this slide we are talking about the foundry service process, comparison between indium gallium phosphate and aluminum gallium arsenide HBT, and we will also see the 6-inch HBT process flowchart, front and back, and also we have talked the modeling and modeling procedure, transmission line. We will talk the 3 passive device, capacitor, inductor, and the resistor. We will go through the layout design rule, and also we will at last we will go through the design rule check. Thank you.